Hello students, let me take up a simple topic, surface chemistry. So first of all, you have to understand what is a surface phenomenon. Now, if you consider there are two phases, so for example there is a solid. On the surface of a solid, if the particles accumulates, it may be solid, liquid or a gas. If it accumulates on the surface, then we can call it as a accumulation or adsorption. Now this is one of the examples for surface phenomenon. Now the question I'll ask, what is surface chemistry? Surface chemistry is the phenomenon which occurs at the interface of two phases. If you consider there are two phases, in between them whatever the phenomena taking place, that is called surface chemistry. Okay, so in this chapter we will discuss about adsorption and absorption. Just one letter difference, but there is a lot of difference with the meaning and the phenomenon. Now the first question I'll ask you, what is adsorption? Okay, all of you saw the sugarcane juice, you tasted. What is the color? It's a pale yellow color. What is the color of a sugar? It is colorless. So how it is made colorless? It is by the phenomenon of adsorption only. On the animal charcoal, the decolorization is done. Now I'll give you one more example for adsorption. It is easy again. Suppose if I take a closed container in which the charcoal pieces are kept. Suppose the gases like hydrogen or ammonia or carbon monoxide is filled inside this. After some time, the pressure of the gas inside the container decreases. You may ask why the pressure decreases after some time. The reason is simple. The gases gets accumulated on the charcoal, which reduces the pressure. Okay, so many such examples you can give. Suppose if I take in a container some organic dye, maybe methylene blue or some other colored substance. If I put animal charcoal to that, okay, consider this is animal charcoal, and if I put some coloring substance and after shaking this container, the color of the solution becomes colorless. Why it is happening? Again the coloring substance which is present on that, it is getting adsorbed. So with these simple examples, try to understand what is adsorption. It is a phenomenon of accumulation. As I told you already, if there is a solid, on the surface of a solid, if the particles accumulate, if it remains on the surface, there must be some bond. It may be a weak bond or a strong bond, but there is an accumulation of a substance. Okay, so that accumulation on the surface is called adsorption. So coming back to the definition, what is adsorption? It is a process of accumulation of liquid or gas molecules. Generally there may be solid molecules also accumulating, but it is generally liquid or gas molecules accumulating on the surface. Okay, so the definition is easy. It is a process of accumulation of molecules on the surface of a solid. When I started with this chapter, I told you there is a phenomenon at the interface of two phases. So in this adsorption, suppose if I consider the solid on which accumulation taking place, this is one of the phase, and the liquid or gas molecules which are accumulating, it is another phase. So now these adsorption phenomena, if you study in detail, it has got the two components. What are the two components? Can you guess, students? The one, the solid here where the accumulation taking place, and the another one, the liquid or gas molecules. Don't expect that it should be only one layer of molecules. It may be many layer of molecules accumulation possible. Now, if there are two components here, we can study the components of adsorption as the first one. Remember, there are two components. As I told you, there are solid on which accumulation taking place, and other one is a liquid or a gas. So the first component is adsorbent and other one is adsorbate. Okay, so what is adsorbent? Simple. In this accumulation process or in this adsorption, the solid on which accumulation taking place, now I can call it as adsorbent. Okay, the liquid or gas molecules which are accumulating, it is called adsorbate. Okay, so this is very easy about the adsorption. Till now you understood what is adsorption, the definition, and you understood the two components. Okay, so simple. Let me repeat. Adsorbent is the solid on which the accumulation of the molecular species takes place. Okay, adsorbent is a solid on the surface of which the accumulation is taking place. Adsorbate are the particles or the molecules which accumulates on the surface of a solid. Okay, so now when I consider there is an accumulation, the particles remains only on the surface. I mentioned in the beginning, in this chapter we study about adsorption and absorption. Okay, the question you may ask now, is it adsorption and absorption is totally different? Now, what is absorption then? Easy. Suppose if I take a plastic sheet, if I put some drops of water on that, the surface of the plastic sheet is wetted by water, no doubt. The water droplets remains only on the surface because plastic will not absorb water, it will remain only on the surface. Instead of that, suppose if I take a tissue paper or a blotting paper or a cloth. Now, the water molecules, the particles of water, it won't remain only on the surface, it will move into the surface. Suppose if the particles move within the surface or it penetrates inside the surface, then we call it as absorption. Okay, now what is absorption then? Is it a process of accumulation? No, it is a process of penetration. The particles are moving inside. The simplest example what you can remember, if a sponge is dipped in water, the water molecules won't remain only on the surface, it will enter into the surface. So the process of penetration of the molecules into the surface of a solid is called absorption. Okay, so adsorption is a surface phenomenon. It happens only on the surface. The particles remain only on the surface. But in case of absorption, the particles are not found only on the surface. It is found within the surface, means the particles are penetrating into the surface. Okay, now let me ask you one small question. Suppose if the adsorption and absorption takes place simultaneously. A simplest example I'll give you. I will take a chalk piece and I'll dip it in a colored solution. Okay, when I dip a chalk piece in a colored solution, the particles which are responsible for the color, that will remain on the surface, that you can see the color of the chalk piece will be changed. At the same time, the liquid content present in the solution, or I can say the solvent, it will penetrate into the surface. That makes the inner sides or the inner part of the chalk piece is also wet. Now, here what happened? The colored particles are accumulating on the surface. There was an adsorption phenomena. And the solvent particles are moving into the surface. There is an absorption. Now, if both adsorption and absorption is taking place simultaneously, then that process is called sorption. Okay, sorption is a process where both adsorption and absorption is taking place simultaneously. Okay, now one more thing you may ask. After the process of accumulation, suppose if the bond between the particles breaks, if the detachment of the particles takes place, then what is that phenomena called? The reverse of adsorption is called desorption. Students, we are discussing only the introductory aspects of a surface chemistry today, where first you understood what is adsorption. It is a process of accumulation of molecules on the surface of solid. Then you understood the two components in adsorption, that is adsorbent and adsorbate. Then we understood what is absorption. Okay, just now I told you the phenomena both adsorption and absorption taking place simultaneously is called as absorption. And remember the one more term which is also very basic here, desorption. It is a process of separation of the molecules, means the accumulated molecules, if it gets detached from the surface, then it is called desorption. Okay, so we understood some basic definitions here. After this we have to understand, if the particles accumulates on the surface, I gave you simple example of decolorization of sugar. I told you example of the decolorization of some organic dye. Okay, in all these cases what we understood, there was a phenomenon of adsorption. Okay, and after accumulation the particles may get detached also. If the accumulated particles getting detached, it is called desorption. So what is desorption? It is a process of separation of the particles which is accumulated on the surface of a solid. Okay, so now repeatedly I told you the accumulation takes place on the surface of a solid. You may ask a question, why it should be on the solid surface only? Why not on the liquid surface, or why not on the surface of a gas? The interesting is, on the surface of solid, the accumulation becomes more convenient. And on the surface of a gas you can't say easily, there is no clear surface. On the surface of liquid also accumulation is possible. But interestingly you have to understand, after the process of accumulation, there will be formation of some weak bonds, some interaction exists. Depending on the force of attraction between the adsorbate and adsorbent, we can study the different types of adsorption. Okay, there is basically we have to understand the two types of adsorption, physical adsorption and chemical adsorption, that I'll discuss in the next class, the various aspects, the differences between them. But fundamentally what you have to understand, what happens to entropy, what happens to enthalpy. You all studied in the first year syllabus thermodynamics. You know, whenever the gas molecules accumulates on the surface of a solid, what happens to enthalpy? You know what is enthalpy? The heat content, the heat is liberated or absorbed. On that basis you say the process is exothermic or endothermic. Okay, now my simple question to you, if the gas particles or molecules accumulates on the surface of solid, what is the change in enthalpy? What is the process? Is it an exothermic process or endothermic process? We know, simple, I told you just now, if the particles accumulate, there is a formation of some bonds, and formation of bonds liberates the heat. So generally we say, in general, the process of adsorption is exothermic. It is exothermic. So when you study about adsorption, you have to remember the thermodynamic aspect of this. It is generally exothermic, means during the accumulation of the particles on the surface of solid, heat is liberated. Okay, after understanding about enthalpy, I told you it is exothermic, right? Now you have to understand, what about the entropy? You know what is entropy? It is a measure of randomness, we say. And whenever a solid converts into liquid or liquid converts into gas, we say entropy goes on increasing, the randomness goes on increasing. And during this phenomenon of adsorption, what happens to entropy? Anybody can guess. Here the particles are randomly arranged earlier, and when it accumulates they come closer, the randomness decreased. So entropy decreases. Now coming to the sign convention, when you say the process is exothermic, in case of adsorption phenomena, the delta H we represent it as a negative. For all exothermic processes, delta H is negative. Now what about the entropy? The randomness, I told you, it is decreasing, and generally we calculate entropy delta S as Sp minus Sr, entropy of the product minus entropy of the reactants. So after accumulation the randomness decreased, means the entropy, the sign of delta S will be, can you guess, the products or after accumulation the entropy is less, this is also negative. Okay, so when process is exothermic and entropy is also given delta S is negative, we are curious to know the process, is it spontaneous or non-spontaneous? Okay, which is that expression used to calculate the or to predict the process is spontaneous or non-spontaneous. Okay, you all studied Gibbs equation, delta G is equal to delta H minus T delta S. It's a repetition from first year. Delta G is equal to delta H minus T delta S. Let me substitute the sign here. Delta H is negative because the process is exothermic. Minus from the formula T, whatever be the temperature, because I told you the process of adsorption of different types, and some may happen at low temperature, some may require high temperature. The temperature is not a factor now. Delta S, I told you, it is negative. Okay, when you simplify, this is minus into minus, it becomes plus. No doubt the answer can be negative or positive depending on the temperature, but generally what we say, since it is an exothermic process, there is a liberation of heat which tries to decrease the energy. The process is spontaneous. Okay, so this process is spontaneous, and I told you the delta H is negative. This usually asked for a 1 mark question in adsorption phenomena. What about the enthalpy change, entropy change, or is it a spontaneous or non-spontaneous? Okay, so whatever I told you till now, it's all the basics, all the fundamentals only. I didn't go in detail to the term adsorption with the different types, but just to recollect back, okay, before we go to the types of adsorption in detail, I told you what is surface chemistry. The phenomenon which happens at the interface of two phases. Then I introduced the term adsorption, that is a process of accumulation of molecules on the surface of a solid. Then along with that we understood the two components, adsorbate and adsorbent. The solid on the surface of which the accumulation taking place is called adsorbent. The liquid or a gas molecules which accumulates on the surface of solid is adsorbate. Okay, then we understood what is absorption. It is a process of penetration of the molecules into the surface of solid. Okay, and I told you the term sorption, you recollect, the term sorption stands for both adsorption and absorption taking place simultaneously. Then I told you what is desorption, process of detachment, accumulated molecules getting separated from the surface of solid. Okay, and then we understood the terms of thermodynamics here. What about enthalpy, entropy, and the spontaneity of the process? Okay, so this is very easy aspect of surface chemistry as fundamentals. Okay, in the next class we will discuss in detail about the different types of adsorption. Okay, just remember some of the examples. I told you decolorization of sugar or decolorization of solution, or a simplest example if I use this marker to write on the board here, the particles of this will stick on the surface. This is a example for surface phenomena. It is nothing but adsorption. Okay, next class I will explain about the types of adsorption in detail. Okay, thank you.